Good morning, my grade 7 learners and the grade 7 teachers. I hope you are doing fine up to now. This is the last lap of the academic year 2021, and I believe that you have started well with your term 4's work. Now, today I'll be taking you through the surface area and volume of a rectangular prism and the cubes. The last time Mr. Nduli did with you the perimeter and the area of two-dimensional shapes. Now our focus today, to build on that, it will be on the surface area and the volume of the prisms. Particularly, we'll be looking at rectangular prisms and the cubes. Thank you very much. In the first activity that we are going to do, we are going to be very practical. We are going to investigate first so that we have a better conceptual understanding. Now, let us quickly now look at the presentation outline for this lesson 1, which is combined with lesson number 2. We will look at the surface area, use appropriate formulae to calculate the surface area and capacity of the cubes, as I said, as well as rectangular prisms, and describe the interrelationship between the surface area and the volume of the objects as mentioned above. Thank you. Now, before we start, let us have a look at the concept, the surface, or that term. What does it actually mean? Because we normally say, let us have this vocabulary words, read and understand them before we can go and see their application. Now I had to consult a Cambridge Maths Dictionary. I hope all our school libraries or in our math labs, we have these dictionaries. Now, according to the Cambridge Maths Dictionary for schools by K. Press, a surface is an exterior or the outside face of an object, and the flat faces of a solid are all what? The faces. Now, any flat area such as the floor of your classroom, the ceiling, the walls, or top of a table is also called a surface. Now, what is a surface area according to this Maths Dictionary by K. Press? He further says the surface area of a solid is the total area of all its exterior surfaces. Let us recap. A surface is an exterior or the outside face of an object. The flat faces of a solid are all faces. Then we further say any flat area such as a floor or the top of a table is also called a surface. Now I'm sure now you can picture this, or you can have a look around your classroom, then you have all these surfaces. Now the surface area. The surface area of a solid is the total area of all its exterior faces. For an example, last year I'm sure you have done all these prisms. Think about a rectangular prism or a cube to be precise. Let us look at a cube. A cube has got how many faces? You'll agree with me that will be the 6 faces. Now, if we find or we determine or we calculate the area all the 6 faces, then we add them together, all of them, then we will end up with what we call a surface area. Now, as I said, you need to have the following: your ruler, a pencil, and an A4 paper, so that I want us to investigate how to make a net of a cube. I am aware that our DBE workbooks, they have this pre-planned or pre-printed nets at the back of the book. But I want us to get our hands dirty and try to investigate the surface area of a cube by creating one for ourselves. Now, this will be the steps that we are going to follow. Have your A4 paper with a ruler clearly marked with its measurements, whether in centimeters or in millimeters. Then you have your pencil or a ball pen ready and a pair of scissors. Now, if we take a A4 paper, let me project this. The A4 paper, a clean A4 paper, a ruler, and a pencil, so that we have a rectangular prism. We are going to investigate the surface area of a rectangular prism or a cube. Let us focus on a cube for now. Now we are going to create or develop a net for ourselves now. Forget about those pre-printed ones. Let us check. You have your ruler, put it on your A4 paper. Now let us take the measurement. And we can see from 0 centimeters up to where this A4 paper ends is exactly 210 centimeters. And therefore, put your paper in another position, and therefore, let us find or check where the 210 centimeter is. It will be here. Then you make a mark, and therefore now let us have a straight line where we say, okay, I am going to cut off that paper because we said we are only going to focus on a square. Take a piece, your pair of scissors, then we're going to take off or cut off this extra sheet of paper. Then now, if you have measured correctly, you will end up with a square paper like mine. And therefore, from this one now paper, you can fold it anyhow, but make sure that you fold it into 2 equal parts. They must be equal. The 2 equal parts. And therefore, take a pair of scissors, cut it into 2 equal parts, exactly on the mark. Then you will end up now from a square paper, you will end up now with 2 rectangles. 2 rectangles, take one, fold it to its longest side. You fold it to have exactly each part facing or laying exactly on one another, and therefore, as you can see, this is our what? Our line of symmetry. Therefore, cut it again into 2 equal parts, exactly on the mark. Make sure that you are accurate. It has to be accurate so that we end up with what we have or what we want. Now I have another smaller now rectangles. Can you see them? The 2 rectangles. And therefore now let us fold them into 4 equal squares. Therefore I will fold this, and therefore I will end up with what? With the 2 layers. Therefore, fold it again for the second time, and therefore now let us check. You will end up now with how many layers? It will be 1, 2, 3, 4, and therefore unfold it, and therefore you will now end up with this object. You will now end up with this object. Can you see? And therefore, put it aside. Take another one, that small rectangle, fold it again into 2 equal parts, and therefore what do we call this line? It's a symmetry line because it divides this rectangle into two equal parts. Now fold it for the second time. If you fold it for the second time, therefore let us count the number of layers that you have now. 1, 2, 3, 4. And therefore, now you can fold this side to the opposite direction, and therefore now you will end up with this kind of objects. And then now you take your bow stick, and therefore you put them together, and therefore you will end up now having what? You will end up having a cube. This is the end product. And therefore now, with this cube now, let us write the number of sides in this little cube. This is the first one. I have 1, and then I have 2. Let us number them: 2, 3, and then 4, and then 5, and therefore where is the sixth side? This will be the sixth side. Now can you see we have investigated for ourselves that a cube, this is how to make a cube, and therefore how many sides does a cube have? It has now 1, 2, 3, 4, 5, and 6. Therefore, there are 6 flat faces, or the faces in a what? In a cube. Then now I would like us to take a ruler. Again, let us measure the face of our sides. It measures what? 5 centimeters. Check another one. It is 5 centimeters. Check the next face. It will be 5 centimeters. It is 5 centimeters. And the last one, the sixth face, therefore, it also measures exactly 5 centimeters. Now, from the definition, we said the surface area of a solid is the total area of all its faces. Now, for us to get what the surface area of this cube, it means I will go to the first face, this flat face, and therefore let's check. If this face, therefore if we have now to unfold this cube, we will have this picture. Therefore, let us find out what is this two-dimensional shape. It is a square, a square, a square, a square. Therefore, a cube is made up of what? It is made up of 6 squares. So it means those squares are of equal length or equal size. And therefore now, if we want the area of this two-dimensional shape, we'll say this is a length from here up to there. And also this will be another length. We have measured it. And then we said it measures 5 centimeters and then 5 centimeters. Now, what are the properties that you learned in the previous grade, that is grade 6, of a square? The opposite sides of a square, or all 4 sides of a square, are exactly the same length. They have the same length, meaning this side will be 5 centimeters, and also this side will also measure 5 centimeters. And therefore now, what will be the area of this first square? The area of this first square. Then we'll say what? I'm sure you still remember that the area of a square, the area of a square will be given by the area. It will be what? The side multiplying by another side. Or if you like, you'd say length multiplying another length. And therefore, what is the length of the side? Then we say the area of that square, it will be 5 centimeters multiplied by another side, or the length, it will be 5 centimeters. And therefore now, let us do the calculation. 5 multiplied by 5, it will be 5 by itself 5 times. Let's go. What is 5 times 5? 5, 10, 15, 20, 25. Then we have 25. And therefore, luckily, you have done the exponents. Now you will know what will be a centimeter multiplying by another centimeter. Then we will be having 25 centimeter square. Therefore, this means that the square of the top side is 25 centimeter squared. And what will be now the area of side 2, the flat surface number 2? We said they are of the same size. Therefore, this will also be 25 centimeter squared. And therefore, the third side or face, 25 centimeter squared. And therefore, side number 4, exactly 25 centimeter squared. That is what? The area. And therefore, the fifth side or face, exactly 25 centimeter squared. And the last sixth side of a cube, also 25 centimeter squared. And therefore, let's go back again to the definition. The definition said, according to the Math Dictionary, the surface area of a solid in this case we are referring to what? To a cube, is the total area of all its exterior surfaces. Now we have how many sides? We have the 6 sides or faces, and each of them, its area is what? Is 25 centimeter squared. Therefore, for how many sides? It will be the 6 sides. And therefore, if we want the surface area of this cube, I'm sure you will agree with me. We'll say, okay, 25. Okay, let me take a clean A4 paper just to demonstrate the calculation. We'll say, okay, the surface area will be the total of all the areas of the 6 faces. So it will be the first face, it was 25 centimeter squared plus 25 centimeter squared plus another 25 centimeter squared. It's 1, 2, 3 plus another 25 centimeters squared plus 25 centimeters squared of the fifth size, 1, 2, 3, 4, 5, and the sixth side, because it is all the total area of the faces. And then now we will add 25 plus 25, I think it will be 50, 75, 100, 125, 150, and then we'll say this surface area of our cube, that we have created is 150 centimeter squared. I'm sure this is clear. Now let's continue. This is what we did when we were creating a what? A cube. Now, number each face on the cube, and how many faces does a cube have? We said a cube has 6 faces. We have answered that question. Number 3, measure the side length of each or one face of the cube. We have measured the length of all sides, and we discovered that it is what? 5 centimeters. Now, if we have to find the area now of a what? A 2-dimensional flat face of this cube, of which is made up of 6 squares, we said the area of each face will be 25 centimeter squared. Number 4, calculate the area of the face of the cube. This is what we have, and then we have also indicated this on our cube, that is 25 centimeter squared. Now number 5 is saying, add up the areas of all faces. This is now what we did here. We said now there are 6 sides, and each area is 25, and therefore we'll have what? 25 plus 25 plus 25 plus 25 plus 25 plus 25. We are still fine. Now, let us check here. Now, this is a worked solution now. We said, okay, a cube has got 6 faces, and each, we have seen, has measured exactly 5 centimeters. And then the area, we said, okay, the area, it will be one side multiplying by another side, and that will be what? 25 centimeter cubed. Now, if we want now the area of all the faces, we said it will be all the 6 25s added together, and then we'll end up with what? 150 centimeter squared. What does this mean now? So that we shorten this, because we know that in mathematics, we work with some kind of formulas, but now we need to investigate for ourselves, as we did as to from where do these formulas or the shortcuts come from. Now we're saying the surface area of a cube, meaning it will be the 6 multiplying the length by the length. Why are we saying the 6? The 6, it is because of the 6 faces, flat faces that we have in our cube. And therefore, the length, it will be this length if we are looking at this flat surface, which is a square, and multiplying by another length. Or others refer to it as a side multiplying another side. We are looking on the top part of this cube made up of what? Equal squares. And therefore, hence we are saying it will be a length multiplying by another length. But now how many faces? 6 faces. Hence, we are having 6 multiplied by length times another length, of which this will be what? I said earlier, you have done what? The exponents. Now we have inside the brackets L multiplied by L. Let me just demonstrate this. If I have, say, the A multiplying A, and therefore this will result into what? We know that as you were dealing with what? The exponents, that if it's not written, it means the exponent is 1, and then it's 1. And what is this A? It's a base, and 1 is an exponent or a power. And therefore, Because now the base are the same, then what do? We will add the exponents, and then we will have a multiplying by a, it will be a to the power of 2. That will be a to the power of 2, or a squared. That is why we are having now here 6 multiplying L by L, which now result into 6L to the power of 2, or 6L squared. I think this is clear. Now, as we summarize now this one, we're saying the surface area of an object is the sum of the areas of all its faces, or the outer surfaces. As for other areas now, we will see at the later stage that we measure the surface area in square units. For an example, in millimeter squared, centimeter squared, and even the meter squared. Let us continue. We are now continuing. I think you have seen this in real life situation, because math is real. A cube, I'm sure you have seen how a die looks like. A die is an example of a cube. How many faces are in a die, and it's numbered with those white dots. For an example, let's focus on this die on the picture. It's a red die. It is numbered in terms of dots in white, and therefore meaning it is marked from number 1, that will be the first flat face in the die. The second one, it will be marked by 2 dots, 3 dots the third one, the fourth one, up to the 6th one with 6 dots, indicating clearly that there are how many flat faces on a die? There are 6. I'm sure you have seen this, and then you have played some of these games. Therefore, that was all now about a what? A cube. Now we are going to move on to the next one, because we said our focus for today, it will be the surface area of cubes and the rectangular prism. Now let us have a look at the second one. I'm sure you have seen this kind of a box. It is a matchstick box, and therefore how does it, or what do we say this shape or this object in mathematics is? Then let us identify this matchbox. It is a rectangular prism, and a rectangular prism has got how many faces? It has the 6 faces. But now let us make sure that they are 6. I have here a matchbox, and therefore how many faces? Let us count. It will be the top part with a picture, and therefore we can say this, it is face number 1. Can you see? And therefore it is the top part. Now let us move on. For us to move to the next face, go to the opposite direction, or the opposite side of face of the top face, meaning obviously that will be the bottom face. It will be number 2, and therefore let us now check here. If I'm saying this is the front of this rectangular prism, then we marked it number 3. It means the opposite one will be the back side. That will be number 4. And therefore, this side now, on my right hand side, I would say this is number 5. And therefore, the opposite of right will be left, and therefore this will be my left side, of which it will be number 6. clearly now, just like a cube, a rectangular prism has got 6 faces. One bottom, the top one is the first, the bottom is the second, the front is the third, the back side, it will be the fourth, and the right hand side, it will be the fifth side, and the left hand side, it will be the sixth side. Now we're saying a rectangular prism has got 6 faces as well as a cube. But now we are done with a cube. Let us keep focus on a rectangular prism. I decided on this picture because I know for some reason all of us have got or came across this kind of an object in our lives. Thank you. Now, let us look now at the net of a rectangular prism. We have seen and investigate as we started the one of a cube. Now our focus now is on a rectangular prism. Now, it is sometimes easier for us to be able to see all the faces of a rectangular prism or a cube, as you have seen, if we look at its net. A net of a prism is the figure obtained when cutting the prism along some of its edges. Now, I am sure you will be aware that these lines here, we call them the edges, the edges, and therefore the points here are the vertex or the vertices. Then we have the edges, the face, and the vertices. All right. Now, here it is said, take a sheet of a paper and wrap it around a matchbox. Now, we're not going to do this one because at least you have an idea as to how to make a net of a what? Of a cube. Then we can do this at a later stage. So, cover the whole box without going over the same place twice, only once. Cut off extra bits of paper as necessary so that you have only the paper that covers each face of a matchbox. Same way as we did when we were doing a net of a what? Of a cube for ourselves. Now flatten the paper and draw lines where the paper has been folded. Remember, those lines now will be what? The edges if we have a prism. Your sheet might look like one of the following nets. There are also other possibilities. But now, let us have a look at these nets, which I have colored it in 3 colors. Then I have blue to blue. Now remember the matchbox. Blue and blue will be the top and the bottom part. Red against red, it will be the front and the back, and therefore the yellow, it will be what? The right hand side and the left hand side of the matchbox. Now this is unfolded, the matchbox. It is now a what? A net. And therefore, if we fold or we put these opposite sides or faces together, we will end up with what? With a box looking exactly like a what? A matchbox. It will look exactly like a matchbox. Now, let us have a look at the dimensions. What are the dimensions? It is the measurement going in different directions. And therefore, in our matchbox, let me show you the matchbox again. We will say this from here, measuring from the left to the right, this, it will be the what? The length. Look at this. What picture do you see here in terms of 2D objects? It is a rectangle. And a rectangle has got a what? A length and a breadth. Can you see? We have a length and a breadth. Now let's go to the front side. Look at this face. It is a what in terms of two-dimensional shapes? It is also a rectangle. So this rectangular prism is made out of what? Of six what? 6 rectangles, but they are not of equal size like we have seen with a cube. And therefore, it will also be the longest one, the length, and then the breadth. But now look at this. Hence we say now the rectangular prism, I'm sure you still remember from grade 6 that it is a 3D object. Now how do the objects and the shapes differ? The 2D shapes, they have a length and a breadth if we are now focusing or putting our minds on a rectangle. A rectangular prism, it will be what? Still the length, the breadth, but there is now the third factor in a rectangular prism. And what is that? That will be from bottom up is what? It is the height. Let's have a look at here. If I put this cube here, and therefore you look at the part down there, therefore up it will be what? The height of this cube. Hence the height is measured from down, up, down. That is what? The height. And I'm sure that each one of you knows his or her height. You must know that. Especially now when you'll be doing some measurement. Therefore, I think the teachers need to give you that as your own investigation. Thank you very much. Now we said, okay, these are the dimensions. You still remember I said the dimensions are what? These are just the length going the what? Same direction. Now, this a rectangular box here, which is a prism. The dimensions are, the B is the breadth. It is measured 4 centimeters. The height is 1 centimeter. And the length, its length is what? Is 5 centimeters. Notice that there are 6 rectangles in the net. As I said, showing you the matchbox. Each matching a rectangular face of the matchbox. Point to the 3 pairs of identical rectangles in each net. I said the bottom part and the top part are identical. They are the same. The left and the right are also identical. You look at the front part and the back part or side or faces, they are exactly the same. Now, when we are talking about 2 pairs of opposite sides that are identical in this rectangular prism, it will be the top. It is the same as the bottom. The front and the back, the right and the left. Now, let's have a look now and continue. The length here is what? It's 5 centimeters. The breadth 4 centimeters. And the height is 1 centimeter. Now, use the measurement given to work out the surface area of the prism. How do you find that? You still remember from the definition when we started, we said the surface area, it will be the total areas of all the faces put together. Then now, let us have a look at this. Let us work it out. Let me get a clean A4 paper. And therefore, the dimensions are 5, 4, and 1. And therefore, you have seen that we are now given a rectangular prism. with the length equal to 5 centimeters. The breadth is 4 centimeters. And the height of that rectangular box is 1 centimeters. Now remember, we are saying in a surface area, it is the total areas of all the flat faces that makes up this rectangular prism. Therefore, look now this as a 2D shape, this side, the top part. This will be the length and the breadth. Then now, the length measures 5 centimeters, and therefore I will say, okay, the surface area, it will be what? It will be the top area of the top face plus the area of what? The bottom face plus the area of what? The front plus the area of what? The back face or side plus the area of what? The right hand side plus the area of what? The left hand side. Now let us count how many sides do we have here. 1, 2, 3, 4, 5, 6. Good, because a rectangular prism has got 6 faces. Now, let us check the top part. It will be the surface area. Let us only focus on the top side. The top side, look at the picture in terms of a 2D shape. Is a what? Is a rectangle. Now, how do we find the area of a rectangle? Surely it is length multiplied by breadth. Plus, now I also need to find the area of what? The bottom part. It is also what? Look, the bottom part, if I flip this rectangular or this box, it is also the length multiplied by what? By the breadth. It will be length multiplying the breadth. Plus, now let's go to the front side. This is the front. Now have a look at the front now. Ne? The front side, okay, let me put it like this. The front side, it is the what? Have a look at this. It is the length multiply. Now look at this one now. It is going up from bottom up. And what do we call that? Or what do we refer to that side or length? It will be what? The height. Thank you. Plus, look at the back. It will be exactly like the front. It is also in terms of 2D shape. It is a rectangle. How do we measure the length or the area of a rectangle? It is the length. But now this side is going up in this rectangular prism. Therefore, I will have the length multiplying the height. Plus, the right-hand side. Let's look at the right-hand side. It is what? The breadth. Good. This is the breadth multiplying. Look, this one now is going up. It will be what? The height. Therefore, the left-hand side, we said it is exactly the same because the opposite faces are what? Are identical. It will also be what? The breadth multiplying the height. Now, if we can look at what we have here, we have surface area of this rectangular prism as the length, that is the top side of this rectangular prism, the left side multiplying the breadth side. This one plus the bottom part is also length multiplied by breadth. Now we look at the like terms now. Now we said, okay, looking now at the front and the back, it is length multiplied by the height, and the back part, it will be the length multiplied by the height as well. And therefore, we have now two pairs of identical sides again. It is the back sides, of which each area will be measured as breadth times height on the back, on the left, and then on the right, it is also a breadth multiplied by the height. Then now we can say, all right, let us now substitute, because we know what is our length there. What is the length? It measures 5 centimeters. Now we have 5 centimeters multiplying by the breadth. What is the breadth? It is 4 centimeters. 4 centimeters. And therefore, we know that this is the top part, which is exactly the same as its opposite face, which is what? The bottom part. The bottom part as well, we have the length multiplying by the breadth. What is the length of that rectangular prism given? It is 5 centimeters multiplied by the breadth, which is 4 centimeters. And therefore, we can now say, all right, this will be the bottom part. I'm just putting them with the same color in terms of what? Of the brackets, so that we know that they are the identical parts. That is the bottom and the top part. Then we say, okay, plus. Now we go to the front. The front, we have what? Length multiplying the height. What is the length? 5 centimeters. 5 centimeters multiplying by the height. What is the height given of that rectangular prism? It is 1 centimeters. And therefore we said, okay, let's use color green for the front and the back part. Then we say plus, we go to the back side. It will be what? Length multiplied by the height. So the same dimensions. It will be 5 centimeters, multiplied by 1 centimeters. And therefore, in green, I will have 5 centimeters multiplied by 1 centimeters. And then now we are left with what? The right hand side and the left hand side. Therefore, we'll say plus. The right hand side, it will be what? The breadth multiplying the height. And therefore, let's check. What is our breadth? Our breadth is 4 centimeters. Now we have 4 centimeters multiplying by the height. The height is what? Is given as 1 centimeter. We have 1 centimeter. Therefore, which color? The blue color. And therefore, that was the right part. Now let's go to the right part. The right and the left will be identical. That will be what? 4 centimeter of the breadth multiplying by the height of 1 centimeters. And therefore we said, okay, let us now put that in the blue brackets. Now, we are now left with what? Doing the arithmetic calculations now. Multiplying, let's check. 5 centimeters, or let's say 5 multiplied by 4, it will be 5, the multiples of 5, 4 times, over 4, 5 times. And that will be 20, exactly. Remember, I said earlier, you have learned the exponents. Centimeter multiplied by a centimeter. If I'm multiplying now these units, it will be what? Centimeter squared. Plus the same, because the sides are what? Or the faces are what? They are identical. 5 times 4, it will be 20 centimeter squared. Multiplying it by what? By the front and the back. That will be 5 multiplied by 1. It will be 5 centimeter squared. Plus, it is identical to the back side. 5 multiplied by 1, it will be 5 centimeter squared. And therefore, we are left with what? The two sides, or the two faces, the left and the right. Then we say plus. What is the right? 4 multiplied by 1, which will be 4 centimeters squared, plus 4 centimeter multiplied by 1, 4 centimeter squared. Good. And then now we add. Let us add this. 20 plus 20, it will be 40. 40 plus 5 is 45. 45 plus 5, 50. 50 plus 4, 54. 54 plus 4, it is 58. And don't forget that we need to put also the units of measurements here is what? Centimeter squared. And therefore, the answer will be the area or the surface area of this rectangular prism that measures the length of 5 centimeter and the breadth of 4 centimeters and the height of 1 centimeter. It will be 58 centimeter squared. What is that from the definition? The surface area, it is the total of all areas of the faces that make up this rectangular prism. Okay, let us recap or check it in the worked solution. Exactly like that. The surface area of the rectangular prism that we have, and in this case is what? It's a matchbox. It is the area of what? The top part, the bottom, the front, the back, left and right. And therefore, we are saying, if you look at the shape of the top part, it is a rectangle. And for this, we are going to say the area of a rectangle is a length times breadth. Now we are saying the bottom part or the bottom side will also be what? Length times breadth, because they are identical. The opposite faces of a rectangular prism are identical. The front will be identical with what? The back. And that will be what? The length multiplying what? The height. And also at the back, on the left will have what? The breadth multiplying the height. And therefore, we did the substitution. 5 centimeter multiplied by 4 centimeter, that is for the top part. The bottom part, it will exactly be the same as the top part. That is 5 centimeter multiplying 4 centimeter. Then we add the front and the back, which measures what? The length multiplied by the height. The length is what? 5 centimeters, and the height is given as 1 centimeter. And the left and the right are also the same. It is what? It will be the breadth multiplying the height. The breadth is what? 4 centimeters, and the height is 1 centimeters. Then we have 2 of that. Then we said 5 multiplied by 4, it is 20. 5 multiplied by 1, it is 5. And 4 multiplied by 1, it is 4. But remember the units of measurement here. We're working with centimeters. Now multiplying a centimeter by a centimeter, I have shown you it will be what? The centimeter squared. Then we end up with what? The top part is 20 centimeters. The bottom part area is 20 centimeters. The front area of the rectangular prism is 5, as well as its back side. And therefore the left and the right, respectively, they measured 4 centimeter squared. Then now what do? We add all the like terms. Therefore they are all the same. 20 plus 20 is 40. 5 plus 5 is 10. Now 40 plus 10 is 50. 4 plus 4 is 8. Now 50 plus 8, it will be 58 centimeter squared. Now just like we did with what? With the cube. When we are looking at the surface area of a cube, we can say, now in mathematics, we are now trying to do what? To make things look very, very shorter and simpler. Now we're saying our conclusion from what we did up there, it will be the surface area of a rectangular prism. It will be, look at the bottom and the top. They are the same. Hence I have 2 of length times breadth. And then you look at the front and the back, therefore we shortened that, and then we say, because they look exactly the same, we can say L times H plus L times H, it will be 2 open brackets L multiplied by H, because those are the like terms. The same will apply with what? The right hand side as well as the left hand side. That will be what? 2 of the breadth multiplying by the height. And this was not given. This is something that we have discovered, that in a rectangular prism, we will have 2 opposite identical sides. That is the what? If we do the recap, the top, bottom, that is the pair number 1. Pair number 2, the front and the back, and the third pair will be the left and the right. Hence, we are now saying, all right, we can say this is the shorter way of writing the surface area. We're saying is what? 2 length multiplied by breadth plus 2 length multiplied by height plus 2 breadth multiplied by the height. And therefore, this is what? Now it is termed as a what? As a formula to calculate what? The surface area. But I didn't give you this formula from the onset. This is something that we have concluded to say that this is the shorter way of writing the surface area. And wow, this is exactly or obviously the formula to calculate the surface area. Now that will be the end of the lesson that was focusing on the surface area. The surface area of the cubes as well as the rectangular prisms, the surface area. Now, after a short break, we will now be looking at the next lesson that will be focusing on the volume. Because now, for us to understand the next lesson, we need to master and understand what we did in the first lesson, which was built from the last presentation that was on the area and the perimeters of the 2-dimensional shapes, which were done by mesting tool. And therefore, we're building up to say now we're looking at the surface area. And then after a short break, now we will be engaged in another lesson, which will be now be focusing on the volume of the objects. Thank you very much.